The Greenhouse Effect, Historical Perspective. A 1978 internal report from the Exxon Research and Engineering Company explores the scientific understanding and projected impacts of rising atmospheric carbon dioxide levels at that time. Understanding the mechanism, the greenhouse effect is defined by the Earth's atmosphere trapping infrared radiation that would otherwise escape into space. While solar energy enters the atmosphere, the accumulation of CO2, primarily attributed to the combustion of fossil fuels, slows the radiation return, leading to a warming of the lower atmosphere. Researchers in 1978 noted that atmospheric CO2 concentrations were rising steadily, as evidenced by monitoring sites like the Mauna Loa Observatory and the South Pole. Climate predictions and uncertainties. The report highlights that the models available in the late 1970s were in a primitive stage of development. Key takeaways regarding these early projections included temperature projections. A doubling of atmospheric CO2 was estimated to produce a mean temperature increase of 2 degrees Celsius to 3 degrees Celsius globally, with a significantly higher impact anticipated in polar regions. Modelling challenges. Current climate models struggle to incorporate complex feedback loops, such as cloud formation, ocean heat capacity, and atmospheric circulation, making precise long-term forecasting difficult. Predictability concerns. Some scientists questioned if the climate system was inherently almost transitive, meaning it might naturally fluctuate between different stable states regardless of external inputs. Potential environmental and social impacts. The document considers the consequences of a warmer climate, suggesting that while rainfall might increase globally, its distribution would likely shift. This could move fertile agricultural regions toward higher latitudes. Sea levels, while polar regions might see melting ice packs. Early scientific consensus suggested that the primary polar ice sheets would not melt on the timescale of the projected greenhouse effect. Agricultural shifts, because existing agricultural and industrial infrastructures are calibrated to current climates. Even a favourable shift in temperature and rainfall could cause significant economic disruption for affected nations. Research and policy outlook. By 1978, the scientific community, through international workshops and committees, identified a critical need to better understand the carbon cycle. Researchers believed that the time window, there was an estimated 5 to 10-year window to acquire the necessary data to determine if radical changes in energy strategy were required. Research priorities. High-priority research included determining the exact contribution of fossil fuels versus natural biosphere changes to the CO2 increase, as well as improving ocean-atmosphere exchange models. Strategic approach. Experts at the time advised that while fossil fuel usage should not necessarily be halted immediately, there was a clear need to prioritize the development of non-CO2 emitting energy sources. In summary, the provided document captures a pivotal moment in climate science, documenting both the growing scientific consensus regarding the link between fossil fuel consumption and warming, and the significant uncertainties that existed regarding the speed and severity of those changes.